Hello friends, continuing with the topic of transistor, today we come to its another application, transistor as an amplifier. Today's topic is transistor as an amplifier. First point, we need circuit diagram. Here we have drawn the circuit using NPN transistor. So this is the circuit using NPN transistor in common emitter configuration. Second, components and their functions. TR, this is TR, is an NPN transistor to be used as an amplifier and is in common emitter configuration. RB is the base bias resistance and VBB is base bias battery. RC is the collector resistor and VCC is the collector bias battery. C1 is the input coupling capacitor which couples input signal to base of the transistor and blocks DC due to VBB from reaching the source. C2 is the output coupling capacitor which couples output signal to load and blocks DC due to VCC from reaching the load. Okay. Third step, function as an amplifier. Function as an amplifier we will study in two steps, step A and step B. First we talk of step A, without input signal. When there is no input signal, then how it works. Current IB flows through RB and IC flows through RC. Transistor works in static conditions. Now second step, B, with signal at input, that is when signal is applied at input. Now there are two possibilities, when positive half is impressed and then after it negative half is impressed. So first we take up positive half when it is impressed at input. When positive half at input is applied, it increases the forward bias, which increases IB to IB plus small ib. This IB becomes IB plus small ib. Small ib is the change in base current due to impressed signal, resulting into increase in collector current IC to IC plus small ic. This IC becomes IC plus small ic. This small ic is the change in collector current due to the impressed signal. Now second step, when negative half is impressed at input, it reduces the forward bias, which reduces base current IB to IB minus small ib. This IB becomes IB minus small ib, resulting into decrease in collector current to IC minus small ic. This IC becomes IC minus small ic. Okay. Third, amplification. Since change in collector current is of the order of milliamperes and change in base current is of the order of microamperes, hence there is amplification. Here look at this diagram. Change in base current, that is small ib, is of the order of microamperes and change in collector current, that is small ic, is of the order of milliamperes. So hence there is amplification. We can see this is input signal, this is output signal. Output signal has more amplitude as compared to input signal. So we can say there is amplification. Finally, we say the output signal is amplified as compared to input signal. Fourth, voltage gain or voltage amplification factor, and which is denoted by AV or mu. Since AV is equal to V output over V input and V output is equal to ICRC and V input is equal to IBRB. IC by IB is beta AC. So therefore we write AV is equal to beta AC into RC by RB, which is equal to current gain into resistance gain. So AV is equal to beta AC into RC by RB, which is the current gain or current amplification factor of the transistor. Now since output signal is out of phase with input, therefore voltage gain is expressed with minus sign before the expression. Therefore we write AV is equal to minus beta AC into RC by RB, or it is equal to minus GM into RC, where GM is equal to beta AC by R input, and here R input is equal to RB. Okay. Now fifth, voltage gain of cascaded amplifiers. Now suppose three amplifiers with voltage amplification factors AV1, AV2 and AV3 are cascaded as shown. Then voltage gain AV is equal to V output over V input, which is equal to AV1 into AV2 into AV3. Thus the voltage gain of each amplifier is multiplied, and finally we get the voltage gain of the cascaded amplifiers. Assignment 14 continued. Question number 62. For a CE transistor amplifier, the audio signal voltage across the collector resistance of 2 kilo ohm is 2 volt. Suppose the current amplification factor of the transistor is 100. Find the input signal voltage and base current if the base resistance is 1 kilo ohm. Here is the answer for V1 and then IB. Question number 63. Two amplifiers are connected one after the other in series, that is cascaded. The first amplifier has a voltage gain of 10 and the second has a voltage gain of 20. If the input signal is 0.01 volt, calculate the output AC signal, and the answer is 2 volt. Now sixth part of transistor as an amplifier. Input and output signals are out of phase. Here you can see this is input signal, this is output signal, which are 180 degree out of phase. Let us see how it happens. First we need the circuit. Here is the circuit. Second, components and their function is same as we have discussed for amplification. TR is an NPN transistor to be used as an amplifier. RB is the base bias resistance and VBB is base bias battery. RC is the collector resistor and VCC is the collector bias battery. C1 is the input coupling capacitor which couples input signal to base of transistor and blocks DC due to VBB from reaching the source. C2 is output coupling capacitor which couples output signal to load and blocks DC due to VCC from reaching the load. Okay. Now third, voltage equation of output circuit. Consider the output circuit of transistor amplifier as shown. According to Kirchhoff's voltage law, we have VCE is equal to VCC minus ICRC. Now fourth step, phase relation. Consider voltage equation of output circuit. VCE is equal to VCC minus ICRC. A part, when positive half is impressed at the input, forward bias increases, base current IB increases, resulting into increase in collector current and reduction in VCE. Thus, when input goes positive, output goes negative. This is positive and this is negative. Hence, input and output signals possess 180 degree phase shift. Now, similarly, we discuss for negative half when impressed at the input. Now B part. Again, consider voltage equation of output circuit. VCE is equal to VCC minus ICRC. When negative half is impressed at the input, forward bias reduces, base current IB reduces, resulting into decrease in collector current and increase in VCE. Thus, when input goes negative, output goes positive. Thus, when input goes negative, output goes positive. Hence, input and output signals possess 180-degree phase shift. Thus, we can say input and output signals are out of phase with each other in common emitter configuration. 7th, frequency response. Now, frequency response of an amplifier depends upon type of coupling used in the circuit. Here, RC coupling has been used. This is R, this is C. In RC coupled amplifier, the gain at middle frequencies remains constant over a wide range. It reduces at high as well as low frequencies. Here you look at this voltage gain versus frequency graph. So at the middle frequency range, the gain is constant. At low frequency it reduces, at high frequency it reduces. Okay. Assignment 14 continued. Question number 64. Give a circuit diagram of a common emitter amplifier using an NPN transistor. Draw the input and output waveforms of the signal. Write the expression for the voltage gain. Question number 65. Draw a labeled circuit diagram of a transistor amplifier in the common emitter configuration. Briefly explain how the input and output signals differ in phase by 180 degree. Question number 66. Draw frequency response curve of RC coupled amplifier. Question number 67. Draw the circuit diagram of a common emitter amplifier using NPN transistor. What is the phase difference between the input signal and output voltage? State 2 reasons why a common emitter amplifier is preferred to a common base amplifier. Assignment 14 continued. Question number 68. A part. With the help of labeled circuit diagram, explain how an NPN transistor can be used as an amplifier in common emitter configuration. B part. Explain how the output and input voltages are out of phase by 180 degree for a common emitter transistor amplifier. Question number 69. Draw a circuit diagram of a common emitter amplifier using an NPN transistor. Write an expression for its current gain. Show input and output voltages graphically and explain the phase relationship between them. Thank you so much. Next time we'll take up next part of it, oscillator. In order to understand oscillator, we need to understand feedback amplifier. First we will discuss feedback amplifier, then we will discuss about oscillator. Till then, goodbye and good luck to you.